So we've always heard about Newton's and his famous laws. What are these laws? Stay tuned to understand Newton's laws like they were a piece of cake. Hello everybody and welcome. Today we will be introducing Newton's laws. So let's go directly and start with Newton's first law. Well, actually Newton's first law is one of the most common sense laws on earth. It described the effect of force on objects, what a force does to an object, and we already introduced that. We said that an object cannot accelerate unless a force is applied on it. So what is Newton's first law? Well, Newton simply says that an object remains at rest or continues with a uniform motion in a straight line unless some action causes it to change its motion. In other words, an object that is not moving will not move unless something moves it, and this something must be a force. And an object that is moving will not stop unless something stops it or changes its direction. So yeah, it's kind of common sense. There's nothing new about Newton's first law, okay? Now let's talk about Newton's second law. Well, we've been circling around the terms acceleration, mass, and force for very much, which means that they must be very much related to each other. Well, actually, yes, they are. And this is where Newton strikes again with his second law, which says that a force on an object is equal to its mass multiplied by its acceleration. Mathematically, we can say that Newton's law can be represented using this very simple equation. We can say that the force applied on any object is equal to its mass multiplied by the acceleration of the object. And it's very important that the force is in newtons, mass is in kilograms, and acceleration is in meters per second square. So let's try Newton's second law with some numbers. For example, it says that an object has a mass of 10 kilograms and was pushed by a force equal to F. This caused the object to accelerate by a rate of 2 meters per second square. The first question says, find the force that was used to push the object. Well, simply force is equal to mass multiplied by acceleration. Force, which we want to find, is equal to the mass. What's the mass of the object? Well, the mass of the object, it's clear, it's 10 kilograms multiplied by the acceleration on the object, which is 2. So the answer is 20. And remember that since we are talking about force, is newtons. Okay? Now, if the mass was reduced to half, what would the force be? Well, you can do it by calculation, saying that F is equal to mass multiplied by acceleration, and now the mass is halved. So it's 5 multiplied by 2, and we can say that the force is 10 newtons. Or you can say, since the mass is halved, we can say that the force can also be halved. Okay, you don't even have to calculate it. Now, if the force was doubled for the same mass, what would the acceleration be? Well, actually, we can say that also force is equal to mass multiplied by acceleration. But I want you to know from this example is that doubling the force will cause the acceleration to be doubled. So F is equal to mass multiplied by acceleration. And so we can say that the acceleration is simply the force divided by mass, okay? And since we know that here, acceleration, the force is now doubled, so it's equal to 40 newton divided by the mass, which is 10. So the answer is simply 4 meters per second square. So the idea from the example is to know the relationship between mass and force and acceleration. So doubling the mass will reduce the force, but increasing the force will increase the acceleration, okay? Now, let's talk about Newton's third law, which is his final law we will be talking about. And let's do it by example. So try to push the table with your hand, for example. You will feel like the table or the desk is pushing you back. We said previously that contact forces come from the result of interaction between objects, okay? Now, this means that it takes two objects that are interacting in some way to produce a force, because if there's no interaction between these objects, there will be no force. And here where Newton's third law comes, he said that the interaction between two objects can be represented as two forces having equal magnitudes and opposite directions. And some of you may know it this way. Every action has a reaction that's equal in magnitude and opposite in direction. Well, they both gave the same meaning, and this is Newton's third law. It takes two objects that are interacting with each other, and when they interact, these forces will come in pairs. And the second most important thing, that these forces are equal in magnitude and they are opposite in direction. Let's see this in more detail. Let's try to understand this in more detail. For example, when you are standing on the ground, you are applying a force on the ground called weight. And we will be talking about weight in detail later, okay? So since the weight of your body is pushing towards the ground, as a result, the ground is pushing back with the same amount of force. It's very important to keep in mind that it's the same amount of force, but it's pushing in the other direction. Another example, let's look at this man here. This man here is trying to push a sofa, okay? So let's call the man with the letter M and the sofa with the letter S and G for the ground. So this man is trying to push on the ground with his weight, so he's applying a force from the man to the ground. So let's call it force mg because it's from the man to the ground. As a result, we know that the ground will push back in the opposite direction with a force, and let's call it fgm because the ground is pushing the man with a force that's equal in magnitude but opposite in direction. Another example, for the same image right here, we can see that the sofa is pushing towards the ground because it has a weight, and the ground is pushing in the opposite direction with a force, and let's call it FGS, from the ground to the sofa. Can somebody see another example here? Yes, you're going to say that the man is trying to push a sofa with the force called force MS because it's from the man to the sofa, and we know that this will apply a force in the opposite direction, and it's called force sofa man. Okay, so every action has a reaction that's equal in magnitude and opposite in direction, and this way we have covered Newton's 3 laws. In the next videos we will be solving some problems, so stay tuned.